Hi, this is Subject AI Planning for Autonomy Assignment 2. Contest Pacman Capture the Flag via Group NameCap. The theoretical basis for the design of our agents are breadth-first research, approximate Q-learning for attacking method, and game theory, minimax for defensive mechanism. Refer to the subject material. Q-learning is a reinforcement learning technique used in machine learning to learn a policy. It can identify an optimal action selection policy for a finite Markov decision processes. After the function returns the rewards from the linear combination of our given features game states, the attacking pacman will choose the action with the highest Q value as the next step. We are using approximate Q-learning in our project, and this is the formula. Breadth-first search is a classic algorithm for searching the closest feasible mode in a map. In this project, the movement of pacman to a target point can be determined using BFS with Manhattan distance. The bigger the Manhattan distance, the more steps taken for attacking agent to reach the destination. Our group implements BFS for attacking to reach the nearest food. As talked in the subject, game theory is the study of mathematical strategic models between rational decision makers. We use minimax, which finds the action with the most probability to win finally as the next action. The strategy assumes the enemy used the same strategy as we used, and it regards the enemy as a smart component. Minimax is a strategy for our defensive agent, which can predict the next move of enemy to beat it from our side. I recall the agent performance across different maps with a variety of scenarios. The red attacking agent reaches a random point in the middle line and starts capturing the nearest food. The yellow defensive agent finds one of the 4 closest food to the map center as its defensive anchor. It can be seen that the blue team using the same code choosing another defensive anchor, which is still one of the 4 closest food to the map center. The defensive agent assumes the enemy would regard this food it stands on as a first target, and it can protect food against the enemy. Once the enemy comes into the defensive field, 6 Manhattan distance, it starts running to the enemy until the enemy is over 6 distance or not seen on its side. The defensive strategy is beneficial because it can slightly predict the next step of enemy, and it has higher accuracy for defensive. Our strategy has a pitfall that when the attacking agent located at middle line that can see the enemy, our attacking agent starts escaping from the enemy's side when the ghost is in 3 Manhattan distance. But the attacker is not afraid of enemy pacman when it is on its own side. There is sometimes a stuck in the middle because it keeps switching between the attacking and escaping strategies. Regarding to the challenge in our project, we found Q-learning does not work at the beginning. Then we switched to BFS for attacking strategy. At last, we have Q-learning with a bit worse performance on time consumption for attacking agent, and then we use this method in real circumstances. Our original strategy was to win with no matter how small the score is. Then we did not include capsule in our method, which is a magic point. If we have more time in the future, we would like to include this method for eating the capsule, and we will probably write more game states and features to support agent working under complex maps.